So thank you on the invitation to present this exciting study looking at treating untreated essential hypertension patients with prebiotic intervention. So despite significant advances in early detection and pharmacological intervention, 68% of patients still have uncontrolled or unmanaged hypertension. And current hypertension guidelines around the world emphasize the importance of lifestyle modification as a first-line management for the treatment of hypertension. And this is because dietary lifestyle factors such as dietary intake, lack of dietary fiber, animal-derived saturated lipids, as well as salt, all lead to hypertension, which is a major risk factor for stroke, heart failure, and kidney disease. So clinical evidence supports the view that dietary fiber intake reduces the risk of cardiovascular diseases. A recent meta-analysis published in The Lancet in 2019 showed that with an increase in fiber intake, there was a decrease in coronary artery risk, as well as a reduction in blood pressure. And this is significant because fiber intake is still poor among adults, with the average adult consuming only 15 grams of fiber when the recommended is 25 to 30 grams. And mounting experimental evidence also supports that fiber intake reduces blood pressure. So when we consume fiber, the undigested resistant starches reach the colon where they are fermented by commensal bacteria, leading to the release of short-chain fatty acids. And these are predominantly acetate, propionate, and butyrate. They can feed the colonocytes locally and reduce inflammation, but they can also enter the systemic circulation where they're distributed throughout the body and have distal effects, including reduction of blood pressure. So our lab and others have shown that direct supplementation, especially with acetate and butyrate, lowers blood pressure in experimental models of hypertension. But this is all in mice. What about humans? In my presentation today, I'd like to explore the question of whether supplementation with short-chain fatty acids can reduce blood pressure in humans. So in the experimental models, the short-chain fatty acids were placed in the drinking water so that the mice had continuous high levels of circulating short-chain fatty acids. But as you can imagine, that isn't exactly something that we can achieve in humans. So we set out to find an alternative and landed on high-amylose maize starch. So this is a slow fermenting prebiotic fiber product that is rich in resistant starches, and it's made up of this starch polymer backbone. But what makes it unique is that it can be conjugated with acetate and butyrate so that during the fermentation process in the colon, more acetate and butyrate can be liberated. So I'll refer to this product as HAMSAB diet. And in terms of our hypothesis, we hypothesized that the short-chain fatty acid enriched supplement, the HAMSAB, would lower blood pressure in untreated human hypertension. So our primary aim was to determine whether our supplement would lower systolic blood pressure in the participants with essential hypertension. And our secondary aims was to look at the fecal microbial composition as well as short-chain fatty acid levels. So we designed a double-blind, placebo-controlled, randomized crossover trial, and the participants were screened by our study coordinator and dietitian, Dakota. And following successful screening, participants were placed on either the placebo arm of the study or the HAMSAB arm of the study for the duration of 21 days. After this, there was a 21-day washout period in which the participants were placed on the opposite arm of the study. We collected fecal samples, measured blood pressure, as well as dietary information before and after each diet, and the study protocol was published earlier last year in the journal Trials. So our inclusion criteria was untreated male and female participants with essential hypertension, defined as an office blood pressure measurement of 140 or greater than 140 over 90 millimeters of mercury, as well as a 24-hour ambulatory blood pressure measurement greater than or equal to 130 over 80 millimeters of mercury. So this was open to anyone in the state of Victoria that was 18 to 70 years old, that had a BMI of 18.5 to 35. So in total, we had 157 expressions of interest. Of these, 31 were successfully screened, 21 were randomized into the trial. We had one person that had to drop out because they had significantly high blood pressure needing medication. And in total, we had 20 participants that completed the trial whose data I'll go through today. So we had approximately 30% female participants, and the mean age was 55 and the mean BMI was 25. And we used the office measurements to enroll the participants in the 24-hour ambulatory blood pressure measurements to confirm their hypertensive diagnosis. The diets were quite well tolerated, and we had like 93% compliance, and there was no adverse side effects that were reported. And the diets in terms of energy, protein, fat, sodium, potassium, and so on was exactly the same, with the only difference being in dietary fiber and resistant starch content, which were increased by 40% and over 500% respectively. So the first thing that we wanted to understand was whether or not our HAMSAB supplement could actually increase the circulating levels of short-chain fatty acids. So we looked into the plasma of these participants and confirmed that there was a release of the short-chain fatty acids, acetate and butyrate. So after the 3 weeks on the HAMSAB diet, we found that there was an enrichment of the short-chain fatty acids in the plasma of the hypertensive participants when compared to the placebo, to levels that would not otherwise be achieved through a regular diet. We also confirmed that there was a change in their colonic pH using a smart pill. The data I've not shown today, but you can read about it in the paper. So given that we've confirmed that there's an increase in the short-chain fatty acid levels, we wanted to understand whether there was a reduction in the blood pressure. And indeed, after 3 weeks on the HAMSAB diet, we found that there was a significant decrease in 24-hour systolic blood pressure, with the placebo-subtracted mean difference being 6.1 millimeters of mercury. There was no difference observed in the placebo arm of the study, and we observed no difference between the baseline blood pressure measurements and the placebo. And these differences were independent of age, sex, BMI, and which study arm the participants were on. So we observed similar results when we looked at day systolic blood pressure as well as night systolic blood pressure. And again, these differences were independent of age, sex, BMI, and what study arm the participants were on. But was this change because of the short-chain fatty acid enriched supplement? So we performed a correlation analysis, and based on our analysis, we found that there was an increase in the short-chain fatty acids, which correlated with a decrease in the blood pressure. And next, we looked at other hemodynamic parameters and found that the HAMSAB diet significantly reduced total peripheral resistance, which is consistent with early studies as well as more recent studies that show that the acetate and butyrate are vasodilators. Given this, we wanted to determine whether the HAMSAB diet would change the fecal microbiome. And at baseline, we found that there was no difference in alpha or beta diversity in our participants. However, when we compared the placebo diet to the HAMSAB diet, we found that there was a modulation of the composition of the gut microbiota. We further interrogated the differential taxa and found that the HAMSAB diet significantly increased fiber degraders such as Ruminococcus and Parabacteroidetes. In fact, the Ruminococcus, as you can see in those figures, and Parabacteroidetes were depleted in these hypertensive participants and only increased with the HAMSAB diet and returned back to their baseline. This is consistent with recent studies from our group that identified that Ruminococcus specifically was deficient in hypertensive participants. That was a completely different cohort, and heart failure patients. So this study really demonstrates that supplementation with the HAMSAB diet can restore these critical short-chain fatty acid producing species. So to summarize, the high-fiber dietary supplement, HAMSAB, delivered high levels of acetate and butyrate, modulated the gut microbiota, changed colonic pH, lowered systolic blood pressure and total vascular resistance in treatment-naive participants. Our proof of concept study demonstrates that manipulating the gut microbial metabolites and supplementing with dietary fiber may represent as a new therapeutic option for lowering blood pressure. And with that, I'd like to acknowledge the many people that worked in this project, especially Dakota, our dietitian, and my supervisor, Francine. And thank you.